Hey everyone, welcome over to the pallet rack, or as I like to refer to this shelf, the sea of lost projects and lost souls of projects. On this shelf, we have a few different projects that have been here for a while. They need to be completed or started on, for that matter, and they just haven't done anything in a long time. Right here is one in particular. We need to get this thing out of here and start working on it. Stick with us, I'll show you what I'm going to get into. More specifically, this is the unit that we're looking at here. And this is a hydraulic rotator. Basically, it pins in the top. You supply hydraulic pressure to it, and this bottom bracket here will spin. So we're going to use this for kind of a unique project and see if it works. Pretty sure it will. May or may not spin the speed we want it to, but we're gonna give it a go and see what happens. Now, worst part of this is this thing is heavy, and I put it up here with the forklift, but oh no, Johnny. Poor Johnny number 5 is a little under the weather. The main lift cylinder piston seal is pretty much bypassing pretty significantly. So whenever the hoist is lifted, it shoots oil out the top around the rod. So we need to disassemble old Johnny here and get this cylinder rebuilt, probably the other cylinder as well. And while we're in there, maybe rebuild all the cylinders. But right now, he just can't do any lifting. Wah, wah, wah. I've learned when doing stupid stuff like this, always get your gloves with a hole in it. That way you can have a nice grip and smash your fingers. Oh yeah, it's gonna go bad. Best part is you don't know how heavy it is until you get it off of the shelf. Oh, it's heavy. God. So we're able to get it off of the rack without completely destroying myself or smashing my fingers just yet. Basically, the gist of this is this unit hangs from a pin up here. It can pivot this way, and then when the pin's up here, it can pivot this way. So you'll hang it up here and it kind of will self-center in a straight down fashion. Has some bolts on here that we need to remove. We need to take this bracket off of here. Breaking the old SK 4170 out that we rebuilt from Grandpa's garage. That's the second time this week. The old ratchet worked pretty good. One of the higher load applications, we did skip 1 or 2 teeth because this does have a damaged internal, I guess, ring gear. We just skipped those few teeth, got her in a new position. She's ready to rock and roll. Someone mentioned that you can return this whole thing in a comment section, and I appreciate that because I had no idea. I did get a rebuild kit, but the ring gear was not replaced and looked to be damaged to a certain degree, especially in one specific spot. So I don't know if when you return this to get it rebuilt, do they just press out that ring or they give you a completely different one? I guess sentimental reasons. I want to keep this one. So if that's the option where they just send you a different one, I'll keep this one, and if it breaks, we'll just use it as wall art in the garage. Particular bracket, we do not need these ears up here, so what we're going to try to do is cut this down so it's just this square flange for the bottom of the actuator. The first side went ridiculously bad.
Climbed up on the struggle bus on that one. I was really struggling. Process, technique, I thought I was just going to be able to zip through there. Worked great, but what I didn't realize, I just gouged in about 1/2 inch in the first pass. Then it made it ridiculously difficult to get through there. I cleaned the torch tip. We're going to try to do it again to cut the other side off. Hopefully a little bit smoother. I did gouge it on the first round because I thought, oh man, this has gone great. Not so much. So we're going to fix our sit up here on the floor so we don't completely melt the floor in two. Stop catching boards on fire, and give her another go.
We're through. Woo! I finally managed to work that hole in there, and I had no idea until after we were complete that this milling machine only has a twist drill drilling capacity of 5/8 of an inch. Well, we punched through at 1 inch. We did step up from, I don't know if it was 3/4 to 1 inch, but slowly worked our way up. There she is. It's probably the nicest that's gonna ever look. We got our piece all ready to go over at the welding bench. Got our flat plate that we were working on. What we want to do is take this guy, put it in there like so. During the machining process, made a really nice chamfer here so you can weld on my welding bench. Really nice chamfer so I can fill that all in with weld. My welder isn't necessarily rated for this thickness of material. I need to get the old stick welder out to do stuff like this. We're going to try to fill that in there and then also weld it in the pocket that we made on the backside. So I have two centering V blocks on the weld table. I have one on top lightly clamped because it wants to tip off, but it's going to give me the best chance at welding this.
I usually don't do good in circles. Okay, we strapped it in the lathe to cool it off, but got a little impatient, so I started facing it. As you can see, she's warped a little from the welding. So we have this part faced, the shiny part. And then all the part that's still black is out of the plane. So we need to keep working this out. And it's right on the edge of the limits of the lathe here, but we're gonna give her a go and see what's gonna happen. This is dangerous and a little sketchy, but in theory everything's right. It's clamped in the chuck. We have our center in here, which I re-trued up. So as long as you keep your fingers out of here, everything should be good to go. Here we go. We got that whole surface nice and flat. It's all the same plane and should be running true to the shaft, which is what we're after. Did eat up quite a few tools on that, mostly the high-speed steel tools. Once I switched over to a carbide insert, it went pretty good. This stuff must be, I don't know, maybe a little bit tougher than your regular old steel. Not for sure. Let's get her on there. Are you starting to see what we're after here? This was a hanging basket. Took the hanging basket off, cut it all up, made a shaft, and then we have a pin here. Drop down in the comment section, tell me what you think we're making here. Now I need to get these ears that hang the hydraulic rotator on the front of the tool plate here. So to do that, you need to come up with a shape of how to cut this so it will weld up to there. Obviously this isn't going to work, so we're going to have to try to do something different. Enter cardboard template. What I did here was I took a template, traced it around, cut it out so it's the same shape as what the base plate was. Held it up, moved it around. Couple snips here, snips there, and I come up with a shape that I like. The main goal here is this bottom edge is going to be straight, flat edge, straight edge here and up. So it's going to wrap around the tube in the front face and the bottom edge. This back edge will butt up against the tool plate even though we can't weld it to it. So we're going to weld it here, here, and then maybe put a gusset in this way. That's the plan. Let's trace this out on this piece and then go get it cut out.
Looks kind of like cardboard. Pro tip, when you just cut a hot piece of metal, and you got weeds laying around that you don't want, put that hot metal on your weeds, let it burn itself off. So we got the old Wilton vise and slit in the hitch receiver here. We're going to line up both pieces and then grind them so we have a matching profile. Now I'm sure they're pretty well goofy, but somewhat close, just because my poor torch skills. And let's face it, we just did it with a quick cardboard template. So we're going to sandwich them together and grind them down till they're both the same shape. We just blew metal chunks all over, but we got these two profiles matching pretty close, and we need a 90 here. Right now I'm just going to pop it out of the vise, go test fit it on the skid loader plate and see how it looks. One thing I didn't mention about this bench or this receiver vise that is really cool, when you're tightening it, this thing is fixed, but you pop it and you can move it to wherever you want. That's pretty darn handy. And I need to dig out a little bit more right in there. I can't lie to you guys. I had to take this over to the spigot. It wasn't like boiling water hot or sizzling, but it's still too warm to hold. And we just need to get moving on this. So you can see here we got the pieces cleaned up pretty nice. They're mated. One thing that's a little weird is you can see here that these were kind of on the curve of the part where we cut it. So it looks a little goofy. You'll never notice that. Plate on a cart here. We got the plates that we were working on that we cut and shaped and ground in position. The new pin and the intermediate link. So this is basically what it's going to look like. I know you probably have a really bad shadow with the lighting there, but it's kind of hard to beat with the light here. So basically, these two ears that we modified and cut are going to weld to this tube. And I think we're probably going to put a gusset back. And this intermediate link is going to go right to our rotary actuator or hydraulic rotator. Welcome back to the not so professional weld bench here, i.e. my two-wheel cart. That's just because we wheeled the whole tool plate around. We have our pieces with a nice big chamfer that we ground on there on both sides. We got the intermediate link with our new pin that we installed. It's propped up there. We're ready to weld it. Back at the tool plate where it all started with just a piece of cardboard template on this part of the project. We got the ears lopped off, ground down, welded on to the tool plate that we created out of the old Reese receiver hitch. And I think it's going to be good to go. Do you think it warped or bent? You think we're going to be able to clip it back on here? I sure hope so. And she's on there. Just need to step on a little bit. She's on there. Let's see if we can wrestle this thing on there now. I think I want the fittings to be out the back. Finger pinch 9000 right here. Ugh. Just not quite. Ha ha ha. How about getting the right angle? Scared myself. I thought that was going to be ridiculously hot. It's definitely hot, but I thought it was going to like instantaneously melt my skin. About fell over. Well, we got the hydraulic rotator on the end of the Bobcat and on the end of the tool plate. And I think the mount here is ridiculously overdone. Those big ears that we used, they were from the original mounting plate that was here. This thing hung a large set of pallet forks and would rotate it. We don't have that kind of load here. You obviously could get away with thinner material. But what we wanted to do is capture the bushings that were in there and utilize the bushings and utilize everything that we had available. So these ears were part of the plate down here. Obviously the link here, we reused the bushings. The only thing we had to make brand new custom here was the pin here that attaches the ears, a bushing, and then a end cap. If you don't know what this is yet, drop down in the comments section, take a little guess. We are so close to putting this thing to work. JIC, ORB, MPT, MPTF, all different kinds of names for fittings, and this is like any other plumbing project. You never have the correct fitting. I wanted to just mechanically couple this hydraulic rotator to my fittings here, my steel lines, with this 1/2-inch JIC swivel fitting. Unfortunately, the fitting that was available is a 5/8. No ticky. So after spending way too much time at my local farm store, I was able to come up with a combination of fittings here, and 30 some odd dollars later, I went from my steel hard lines to a 1/2-inch female JIC. So now all we need to do is have a JIC coupler, and our lines will connect right in there and then connect to our hydraulic rotator. Let's see if we can't get this thing hooked up and hope that it doesn't shoot oil everywhere. Here we go. This particular hydraulic rotator is meant to have through porting, so you can have the hoses I just removed were for an actuator down here that would clamp and unclamp. So you'd need those to obviously be ported through. So this is a connection that stays with the spinning part. I just capped those off loosely. We got these up here loosely tied in. Now we're going to see if we selected the right ports, because there's 2 other ports up here. And we either connected to the correct ports or we connected to these clamp ports. I'm not for sure. Let's bump it and see if we get any rotation out of this. Guessed wrong.
If you haven't guessed yet or figured out what it was, we're trying to build a homemade post hole auger. This is a 12-inch auger bit, and right now we're going to see if we can't lasso this on the end of this hydraulic rotator and go drill a hole. Now, every post hole auger unit that you would buy would have a rest that would hold the unit up so it sticks straight out when you're in the down position, tilt it all the way back. I'm on the fence on whether I'm going to install that feature on this. I kind of like to keep this a universal plate and not always have this auger attached to it, because I don't often auger holes. When I need to auger holes, I have to auger a lot of them, but otherwise I'm not going to just use this every other day. If we do come up with something, it'll probably be a quick bolt-on or something that you can add to this and then remove. Let's get this on there. If I had $1 for every time something didn't go as planned, I wouldn't be building my own auger. I wouldn't be using this old skid loader. I'd probably have a brand new one. This big old rock was in our way. I was worried it was something else. All right, we got a hole. I was really determined to make this hole happen with that auger. That's the sole purpose we built that auger. Hello, hello. Got a little distracted. And the auger seemed to work okay until we hit a big rock. We tried to force it through and it just wasn't having it. At some point in time, we pulled it out, hand dug the rock out, and were able to work our way the rest of the way down in the second attempt. And it seemed to work okay. It goes a little bit slow and it does lack the torque that it needs to put this in. When we were attempting to pound this in there, I believe we blew a seal out. Now, that was a hydraulic rotator that I pulled out of the garbage can. So maybe it needed to rebuild upon that time when it was thrown away. I don't know. Or maybe we completely melted it trying to work it into the ground. At any rate, we have a hole and we have a big oil slick over there that we got to go look at. Well, we got us an auger that works. Maybe, I don't know. We may have melted it or self-destructed it in this test, or it may have been in need of repair or rebuild before we even started, because we did pull it out of the dumpster. We won't know till we tear into that further. If you like this video, don't forget to give me a thumbs up. Leave your questions and comments in that section below, and don't forget to punch that subscribe button your way out. Thanks for watching, everyone.